All right. All right, good people. If you hadn't done so, please make sure that your name is at the top of your paper. Please make sure that your name is at the top of your paper. Today is the 5th. The assignments that are going to be due this week are as follows: Q1, Q1, week 2. And we're doing our essential questions, our EQs. They're on the board. We're going to answer those on Friday. Our warm up is due Friday. Our homework is due on Friday. This week, Thursday and Friday, we're doing iReady diagnostic. So we have iReady that we're doing Thursday and Friday. Okay. Think about what you want your goal to be this week. Think about what you want your goal to be. Maybe to make sure that you do homework nightly. Maybe to make sure you get that diagnostic completed. Maybe just to make sure that you are focused. Whatever you want your goal to be, something that you want to work on this week, please put that goal there. And it needs to be academic related, okay? Okay, we're going to pause for the calls, give you a chance to write that in. All right, keep thinking about or writing your goal as I write down the classwork. Remember, you're not required to write this down. This is just for the videos, but you are required to write your homework down, okay? All right, again, this was yesterday's date, the 4th. We had no school here. This was Labor Day. Today is the 5th. Tomorrow's the 6th and 7th, and then the 8th. Okay. Today's agenda, we're going to do the warm up. I'm going to take attendance. We're going to write down our EQ, essential questions, and we're going to write our homework in our planner. We're going to review the system. And if we have time, we're going to estimate. We're going to start estimating roots. Okay. Our homework is labeled Monday in the packet, but we're going to scratch it out and write Tuesday. I'm going to send you a help video in Remind. It is also on Canvas if you have access to Canvas. If don't, no worries. I'll send it to you in Remind. Please write homework. Please also take out your planner and write your homework in your planner, which is to complete Monday's homework. I'm going to stamp your planner when you write it in because that's going to be a form of extra credit for you, okay? Stamped, that means you wrote it. It's a form of extra credit later. Please write your homework in your planner. Okay, I'm going to pause for the calls. All right, good folks, let's write down the essential questions. The essential questions are on the top part of the board. What is the difference between rational and irrational numbers? What is the difference between rational and irrational numbers? The second, we're going to list the perfect squares 6 through 20. You need to know the perfect squares by heart. Remember those perfect squares. The perfect square that's created by 6, 6 times 6 is 36. 36 is a perfect square. 7 times 7. What's 7 times 7? 49 is a perfect square. You need to know all of the ones 6 through 20. You should know 1 through 5. If you don't, please write them. Yes. What do we do when we're done with that? I'm not finished yet. I'm not finished. Yeah, I don't know. List the perfect cubes. And the perfect cubes 1 through 6. So that looks like the perfect cube, the first perfect cube, 1 times 1 times 1 is equal to 1. That's the first perfect cube. The second perfect cube is 2 times 2 times 2. What's 2 times 2 times 2? What's 2 times 2? 4. 4. What's 4 times 2? 8. 8. So 8 is the second cube. And so on and so forth. 1 through 6 are the ones you need to list. Okay? Write the questions. I'm just giving you an example of how to answer them. The questions again are on the front board. The homework, tonight's homework is on the very back page. It's labeled Monday. We're going to scratch out Monday and put Tuesday. Just flip the packet all the way over. It's stapled backwards. Scratch out Tuesday and put Wednesday. And on the back page is Thursday. At the bottom where it says Thursday, we're going to do this part in class. This is Thursday. This one's in class. I'm going to pause for the calls. Please, when you finish writing, put this in your folder. That was a very good question, babe. If you see where it says teacher model, these are the ones I'm doing in the video. Even if you don't watch the video, you still need to make sure you have these completed. Okay? All right, we're going to put this in our folder on the side that says work to do. And there's a sheet that I put on your desk that looks like this. All right. With the people at your table, I want you to, I'm going to give you 4 minutes to do this, to fill out those definitions. The first group that completes them, I do have candy for you. Okay, so this is right here. Make sure that you complete that. I'm going to give us about 4 minutes. That's it. But the first group that completes it, all you're doing is definitions. You can use your notebook if you need to. You can use your notes. You can use each other. But everybody in your group has to have it completed. Okay, so if you don't have it, that's okay. We can write it in. What's the definition for a natural number? Yes. Counting numbers. Counting numbers. Very good, baby. Counting numbers. What's an example of a counting number? Give me one example. Anybody? Yes. 1, 2, 3, so on and so forth. No decimals, no fractions, no negatives. What's a non-example? Give me an example of that's not an example. Yes. 4.146. 4.146. This is 4 and 146 thousandths. That's how you say that number. Okay, because the 6 is in the thousandths place. All right. Give me one more example Non-example. That's not an example. Yes. 1/4. Very good. Whole numbers. What's the definition for a whole number? Yes.
Does it include a fraction, decimal, or negative?
Very good. These do not include. We start at 0, and they have no fractions, no decimals, no negative. No negative numbers. Okay. Give me an example of a whole number. Yes. 1. What else? 21. Don't forget 0. Give me a non-example of a whole number. A non-example. -2. Okay. A fraction, 1/2. Okay. Decimal, 2/10. All right. Those are not whole numbers. What's the definition of an integer? Yes.
Whole numbers and their opposite.
Whole numbers and their opposite. Whole numbers, very good, baby. Whole numbers and their opposites. So these are positive numbers, negative numbers, and 0. No fractions, no decimals. Somebody different. James, what's an example of an integer? What's an example of an integer? Somebody help him. What's an example of an integer? Yes. -2 is an integer. Good job. What's another example of an integer? James, did you figure out one? Can you give me one? -3. Very good. No fractions, no decimals. Okay. And then also +3 and 0. What's a non-example of an integer? Sit up, baby. What's a non-example of an integer? Okay, a decimal. We got 4/10. We got a fraction or even a negative fraction, 1/2. Those are not integers. What's the definition of a rational number? What's the definition of a rational number? Somebody different. Come on. Come on. Yes. Numbers that can be written as a fraction. Numbers that can be written as a fraction. Okay. All right. Give me an example of a rational number. Somebody different. I'm just called on some folks. What's an example of a rational number? Give an example. Come on. What's an example of a rational number? A number that can be written as a fraction. So wouldn't a fraction be an example? Well, give me a fraction. 3/4. Okay. Perfect roots are rational. Give me an example of a perfect root? The square root of what? 25. Very good. The square root of 25 is 1. Excellent. A decimal would be an example of a rational number. Give me an example of a decimal. Yes. 0.25 or 25 hundredths. A repeated decimal, 2/10ths repeating. These are all examples of rational numbers. What's an example of a number that's not a rational number? Yes. Pi is not rational. Okay. What's another example of a number that's not rational? What about a non-perfect root? What would be classified as a non-perfect root? The square root of what? 2. The square root of 2, because the answer is a decimal. When I type in the square root of 2, I get an answer that's a decimal. That's non-perfect. Okay? Connor, what's another example of a number that is not rational?
5.23 ...
Very good. 5 and 23 hundredths, dot, dot, dot. Excellent job. Okay. What's the definition of a irrational number?
Pi.
Pi is an example. Yes, perfect. What's the definition for it? Very good, baby. Numbers that cannot be written as a fraction. Cannot be written as a fraction. Okay, good job. All right, so we got pi as an example. What's another example of an irrational number? Well, that's pi. What else?
Decimal 16. Dot, dot, dot.
Okay, a decimal, 16 hundredths with dot dots on the end. Okay, very good. Give me another kind. What about non-perfect root? Kylie, what's a non-perfect root? Give me an example of a non-perfect root. The square root of 56, because the answer is a decimal. When I type in the square root of 56, I get a decimal as an answer. So the square root of 56 is irrational. Okay? All right. Give me examples of non-examples of irrational numbers. Yes.
Square root of 36.
Square root of 36 is equal to 6. It's rational. Very good. It's not irrational. Give me another example of a number that is, say again. 18. Okay. A fraction. 1/2. Okay. Real number. What's the definition of a real number? Somebody different. Come on, y'all. Yes. Any and every number. Any and all numbers. Okay. So any number that you can come up with, perfect square roots, square root of 25, negative numbers, fractions, decimals. Okay. The only kind of number that is not going to be a real number are going to be the square root of a negative number. That's not a real number. Okay. The square root of a negative number is not a real number. You're not going to see that in this course, but you do need to know that. Any questions?
Is it because the space of the square root would be negative in that case?
No, it's because two numbers, there's not two numbers times this itself that is going to give you a negative, because a negative times a negative is automatically a positive. Got it? That's okay. All right, so real numbers. Every number is going to be a real number. So this block, this big old block, is real number. Okay? Because all numbers are going to be real numbers. Now look at the next to biggest block. It's two kinds of numbers. Either a number is going to be this or a number is going to be this. Real numbers are broken into two different groups. What two groups is a real number broken into? Rational and irrational. Irrational is going to be pi, non-perfect roots, and non-terminating decimals. And those are the decimals that have the dot dots at the end. Those are all irrational. What comes under rational? What's this block you think going to be? Integers. Integers are whole numbers and their opposites. Negative numbers, positive numbers, and zero. No fraction, no decimal. What comes up under an integer? Whole numbers are integers. And what comes under a whole number? Natural numbers. Natural numbers are whole numbers. When we come back from lunch, we're going to paste this in our notebook along with this sheet right here that I gave you on Friday. It's the time management sheet. Okay. If you didn't get this time management sheet, please raise your hand so I can give you one. Okay. I'm going to pause it for the calls. Okay. So make sure in your notebook, take out your notebook so we can paste these two items in. We have on page 7, we're going to put the time management. And on page 8, we're going to put real number review. Okay. Q1, page 7, time management. That's this sheet. I'm going to paste this down. On it, remember, you don't have to fill out Sunday and Saturday, but get a general idea. We know we're in school from this hour to 2 o'clock. Then maybe around 3 is where you do your homework, or maybe some of you take a nap, or you might have practice, or whatever goes on in the afternoon, just to see where your time is. And we're going to paste this here. I'm going to pause for the calls to give us a chance to paste that down. Page 8 is the real number system review. And that's this sheet here. Yes, baby. Which one? Okay. Anybody else need that page 7? Okay. I'm going to pause for the calls to give us a chance to paste that down. All right, good folks. We're moving on to page 9. At the top of page 9, we're going to put Q1 in the corner. This is quarter 1. The title of page 9, we're going to do intro roots, intro to roots. We're going to talk a little bit about roots, square roots, and cube roots, and then we have a foldable that goes along with it. Okay, I'm going to pause for the calls, give us a chance to write the title in. All right, good people. We're going to talk about square roots and cube roots. Okay, so let's talk about square roots first. When you are finding the square root of a number, what does that mean that you're doing? What does that mean that I'm doing when I'm finding the square root of a number? When finding the square root, what do I do? What am I doing? What do you think you're doing? When finding the square root of a number, if I'm trying to find the square root of, and I'm going to do 1, 2, 3, 4 lines, and I'm going to do an example right here. And I'm trying to find the square root of 25. What does that mean that I'm doing? What's the answer here? Yes.
You divide.
I'm not dividing. That is a very good guess, though. What does that mean that I'm doing? What's the answer?
5.
The answer here is 5. Why is 5 the answer? Why? Because 5 times 5, 5 times 5 is equal to the number under the radical, which is 25. So when you're finding the square root of a number, you are trying to find what number can be multiplied times itself to give you the number under the radical. So when finding, I should have put when finding. That is logical. When finding the square root of a number, you let's see, how do you want to say that? Looking for which number or what number can be multiplied times itself. To give you number under the radical. And this is a radical sign. Pause for the cause. The answer could also be a -5. Could also equal a -5. Why -5, Ms. Reyes? Because -5 times a -5 is also equal to a +25. So in actuality, I can write my answer like this. The square root of 25, I could write it as a positive or -5. All right, let's do this one. What would the answer for the square root of 144, what would that one be? What would the answer? See if you can try these on your own. Let's do 256 and let's do 400. Try those. What number can be multiplied times itself to give you this number? Then what number can be multiplied times itself to give you this number? Then what number can be multiplied times itself to give you this number? What number can be multiplied times itself to give you 144? What's the square root of 144? 12. So plus or minus 12. Do you see that? Look. The square root, if we're typing it in, 144 is 12. Okay? Some people put, for this one, it's like what number can be multiplied times itself? Some people put 14. What's 14 times 14? Anybody know? We got to know these by heart. Don't forget, it's 196. Some people put 15. What's 15 times 15? Anybody know? It's 225. And then some people put 16. Nobody put 16 times 16. Did anybody put 16 as the answer? I don't think I saw 16. 16 times 16 is 256. Some people put 18. 18 times 18, look, is 324. Okay? So this is going to be plus or minus 16. And I saw a few answers here. What is the square root of 400? Yes, 20. Plus or minus 20. A positive or a negative 20. Any questions? All right, we're going to stop right here. We're going to stop right here and we'll talk about cube roots tomorrow. Please make sure that we put our notebooks up.